Actually, Ganesh, come over here. Okay, guys, let's start. It's a big room, and we have 4 people in the audience, so good morning. Guys, you want to come closer, if you don't mind? We can actually have a discussion versus us presenting, per se. So, guys, I'm Yusuf Khalidi. Where is the trick clicker? Thank you. Here with Ganesh, and we'll be having a discussion, given it's a small room, about building reliable applications on Azure, guys. Okay? We have plenty of time for a discussion, so I'll try to speak slowly, stop me, that kind of stuff. We also have a nice demo. Ganesh will illustrate the concepts we're discussing here with an actual demo, and we can go through the steps of how to set it up and so forth. Okay? So a bit on the agenda. Basically, we have 2 broad topics. One is how to make your applications highly available and tolerant of disasters, major problems where we lose a whole region, if you will. That's one thread, if you will. The other thread is how to use Azure itself as a disaster recovery site. How to take what you have on premises and then potentially back it up to Azure, or even vice versa. So these are the 2 threads of discussions here. And the way we're going to cover them is by going through a bunch of technology options we have in the system, which you can go and mix and match and put them together for your solution. These are the actual VMs, storage systems, database management, and the thread around all this has to do with hybrid networking, guys, which is actually another talk in the same room by my esteemed partner here. So let's proceed, okay? And guys, please stop me. We can actually discuss things if you want to. Before we go to the actual presentation, I want to just remind you of how we do this stuff in the cloud. In traditional systems, as you know, the focus has always been on reducing mean time between failures, which is building gold-plated systems, expensive hardware, expensive networks, expensive systems like a mainframe if you want to, and optimizing its upkeep, its uptime, if you will. And as much as possible, make sure the mean time between those failures to be very large. So the focus on keeping it up and running. And if something goes wrong, recovery can be long. You have to go run a check disk or FSCK in Unix or whatever the case may be. So keep it running, and if it fails, okay, fine, we'll fix it. The cloud is different. With the cloud, the focus really is about mean time to restore. In other words, we actually expect failures to happen. We do expect it to happen. You have many, many servers, many, many systems. In any given point of time, a given box, a given server, a given switch may fail. The collective has to be up and running, of course, but any given component may fail. Therefore, the emphasis really are on optimizing the time to restore from the failure. And therefore, in these cases, recovery is very, very important. Boot time is very important. The time for an app component to restart is very important as well. And you see it up and down the stack. In traditional systems, a DLL may take a long time to start, to initialize, which is fine. In these cloud systems, you have to be up and running very quickly. So net is the last sub-bullet on the slide, which is apps must be designed to embrace failures. Expect them, expect to reboot quickly, expect to reconnect quickly, expect to repopulate your cache quickly, whatever the case may be. Okay? So let's talk about some technology pieces now. First, let's talk about Windows Azure virtual machines. And let me just stop for a second and ask you, since there's only 4 of you guys, how familiar are you with Azure? Just to avoid going through boring stuff or to go over the basics here. So? Some idea? Okay, good. Okay. So there's a small spectrum here, so I'll go through the basics and we'll go from there, okay? So in Azure, you can basically take your favorite virtual machine, a VHD, and run it in there. Okay? We can host VMs. Now, the question really is how to structure your application, which is built as a bunch of VMs, to be highly available. And we have a concept of basically availability sets, where you can take part of your application, in this example, you may have a bunch of machines which are IIS instances, or in this case, SQL instances. And you put them together in availability sets. What this tells us is that the multiple instances of your application should be managed by us in such a way as if, say, a hardware goes down, a fault domain in hardware goes down, and we are doing a software update, for example, that we lay or allocate the VMs in the proper way. You're basically telling us that your app, in this case, has these multiple entities, and you are able to handle one of them being down, but not both of them being down. That's basically it, really. And if you look at the details of our SLA, the actual stuff that our lawyers write, the legal stuff, I mean, our SLA really, to really attain it, you need to have multiple sets. You have to have VMs in basically availability sets. That's very important. And in this example, this is an example of a real service. Front end talking to a database, very classical. Yes?
You have these two full domains. Are these two full domains the same partition of your application, or are these two also separate partitions?
The way you should view this thing is these are two separate partitions.
Even regional partitions?
No. This is within a region so far. We're talking about...
Let me phrase it differently. If you've got your application, and if I decide that for my end users I want to have, say, a region Spain and a region Holland that run in the same Europe Azure region, would you split those over these two full domains?
No.
That would be the same?
That would be different, to be honest. So the question is, if you want to do things across regions, you would have a picture like this within a given region, and we have a similar picture in a separate region. And the techniques you would use to fail over between them is at a higher level. Okay, I'll mention some in a second, like traffic management or DNS at a higher level. This picture is very much within a region. Okay, across effectively in real life, across racks actually in the same place. Yes. Yes, the question is about load balancing. Yes. Actually, you can actually load balance over these sets. They're built in Azure.
That's built in?
Yes. Actually, same price even.
We have a separate concept called load balanced sets. So basically, availability set distributes the virtual machines.
Can we have the mic on, please? Go ahead.
So the availability set basically distributes the virtual machines across fault and update domains. For us, a fault domain is a single rack, and an update domain is kind of striped horizontally across the rack. So it's purely to make sure that your VMs are highly available. Whereas the load balanced set tells us that you have to expose these two virtual machines to the public internet on this particular public IP address and open up this port. So for us, we have the concept of endpoints. So you define a load balanced endpoint in Windows Azure and say, if you're hosting an IIS server and you want to open up port 80 and port 443, you define two load balanced sets in the platform.
And we'll expand to talk about multi-region in a second, multi-data center in a second. Okay.
So at this point in time, to address your question on how do we load balance across SQL instances, so SQL has a solution called SQL HA. Yusuf is going to talk about it. We have a way to basically deploy a SQL HA cluster in Windows Azure. The standard clustering solutions in Windows that you use, Windows failover clustering, will not work in a cloud environment.
And we have a white paper on this, right?
Yes.
Yes. We can give you a pointer to it as well, specifically for your question. Yeah. Okay. Should stay here. We're close to everybody. So guys, we have a bunch of hybrid technologies in Windows Azure. When we say hybrid, we're referring to you have stuff on premises in your enterprise, in your classical data centers, and you may want to put some stuff in the public cloud in Azure. And broadly speaking, you want to be able to connect them. I'm saying broadly speaking here. So in this picture, there are multiple levels in which you can mix and match to connect your on-premises assets, whatever you may have, to the cloud. And the demo will be something similar in a second as well. So just to go through them high level in a sense, you may have the need to synchronize your data that you have on premises to the cloud. So for example, you may want to have a SQL instance running on-premises, and you want to have one in the cloud, and you want to synchronize between them. And we have options for that. You can do them by hand. You can do them through SQL, etc. We also have a set of technologies around service bus, and we have other talks on this thing. Think of these as queuing and message and application-level messaging. So durable queues and a way for application to communicate across different components, where you can do integration of the application. And in particular, if you have WCF type of interfaces in your application, with service bus, you end up with a namespace up in the cloud. You can do rendezvous, you meet your components there, have durable queues, and exchange information that way. Again, it's optional, mix and match. You can put them in your application set. We'll talk a bit more now, and the next talk about the last two bullets, which have to do with securely connecting your network on-premises to the cloud. Now, we have two offerings in this space. One is the bottom one, which is secure site-to-site, where you can have a VPN device on-premises that hooks up part of your network to the cloud. We'll see quite a bit more about this in a second. And what we have announced recently, a secure point-to-site, where you can take your favorite VPN client in basically Windows machine, if you will, and make it join a network securely in the cloud. Again, I'll say more about this in a second. The point before I leave the slide is this. These are all a la carte optional services for you. You can mix and match them in multiple ways to build the solution you need. And you may mix them to build a solution to have a disaster recovery type of solution, or just to extend your capacity to the cloud. I will repeat in a second the same points. So just give you some examples here. Suppose you have an on-premises system, in this case, the left-hand side of the picture there. It's your on-premises data center. You have assets there. You have a bunch of Windows boxes. You have a bunch of Unix boxes. You have a bunch of Linux boxes. You have mainframes. We really don't care. So you have stuff on-premises here. And you have some things you want to run or are running in Windows Azure, up in the cloud, the right-hand side. With site-to-site VPN, you can take your VPN devices on-premises, and we support a number of them, Cisco, Juniper, F5s, and others, and connect them securely to your virtual network in Windows Azure. And Ganesh will show you more of this thing in this talk and the following talk, how to actually do all these steps. Moreover, you can take actual devices, in this case, laptops, for example, and connect them using point-to-site to the same network. And with the point-to-site, you don't have to have a physical VPN device. It's actually the VPN client in your machine. And doing so, you can effectively extend your virtual network to your data center. You decide what IP addresses you want to have extended and what IP addresses ranges are in the cloud that match what you have, basically the same network you have on premises. You can do things like create subnets, private IP addresses. If you want to, you can bring your own DNS. And if you want to, you can domain join your VMs as well to AD. Again, it's quite powerful. We'll show you an example in detail in a second. Some of the scenarios you may want to use this for are, and again, this is a flavor of the scenarios. You can, for example, do design, implementation, testing, development on SharePoint without actually having any SharePoint hardware on premises. You can set up the whole thing in the cloud. And the demo actually will show this thing and more. You can, for example, do custom internet sites and collaboration apps using the technology I mentioned earlier, purely running in the cloud or mixed with stuff you have on premises. You can use, for example, the cloud to use extra capacity as your business demand increases, maybe seasonal, maybe weekly, whatever the case may be, for bursting type of scenarios. And you can use it for a DR, for disaster recovery. You can run as a mainly on premises and use Azure only for your disaster backup, or vice versa. Run always in the cloud, but if we screw up, bring it up again on premises. All these are options, to be honest. Now, we're going to show you now, Ganesh will show you now an extensive demo of how you can combine the technologies I mentioned earlier, VMs, site-to-site, and the whole extension business to show you how you can do highly available and disaster-tolerant SharePoint system. Okay? You want this?
Thanks, Yusuf. So before we go into the actual demo and look at stuff, there's one thing that I wanted to say. When we started designing infrastructure as a service, the one thing that we thought about was we wanted to support a multi-tier line of business application and actually work towards making one of our in-house products as a key solution. So we picked SharePoint as a workload that has multiple tiers. If you take a look at a typical SharePoint farm, it has a database tier, it has an application server tier, it has a front end, and it has a dependency on identity. So these are pretty much general characteristics of any standard application that you take. So to illustrate all these concepts, what I've done is actually set up 2 highly available SharePoint farms in 2 different geolocales. And the objective is to actually host your intranet site in the cloud and make it accessible from your premises. So in this particular example, I'll go through all the details and show you all the aspects of this demo. I have 2 SharePoint farms, one in our US East region, one in our US West region, both of them talking to my premises using site-to-site VPNs. Again, we've partnered with F5 and a few other new vendors who can actually provide you with a highly available VPN solution. And in addition to that, we use an F5 load balancer on premises to load balance between these 2 sites. So we'll go through the concepts that Yusuf talked about in terms of how we can use availability sets, how we can use load balanced sets, how we can put them all in virtual networks and take advantage of all the aspects of virtual networks. Why is it that we chose to architect some of the aspects of our IaaS offering in a specific way to take advantage of all the key things in the platform? So we'll go through all the aspects in the demo. So if you're new to Windows Azure and have not seen Azure in the past, this is the Windows Azure portal. You would be able to access all your services in Windows Azure through this portal. In addition to accessing everything through the portal, we have REST APIs, PowerShell support, and command line tools through which you can do all the configuration. So for this demo, I actually set up 2 SharePoint farms, and I used a ready-made script that we published in GitHub that enables you to set up a highly available SharePoint farm. So all you do is go to GitHub, install PowerShell in your machines, download the script, and just run it, and it automatically, you provide it your subscription information, and it basically configures the SharePoint site for you, and you can go and tweak it the way you want it at a later stage. So in this particular case, since if you look at Yusuf's slides, the picture shows that there are 2 different virtual networks in each of these regions. So I actually created 2 different virtual networks in 2 different regions, caused them to connect to my premises using site-to-site VPN, and then deployed my SharePoint farm in them. So let's look at the network first, and then let's look at all the virtual machines in the virtual network. So if we go under networks, you'd see that I have 2 VNets, TechEd VNet 1 and TechEd VNet 2. Both are identical VNets. The only difference is that one is in East US and one is in West US. Let's zoom into the one in East US and see how it's been set up, and then we'll look at what is actually inside the virtual network. So if you want to look at the properties of the virtual network, you click on it, and there's a dashboard view. It gives you basic statistics on the virtual network, tells you how much data has been pushed in and how much data has been pushed out, what's the IP address of the gateway to connect to, and a list of all the virtual machines that have been deployed in the virtual network. Actually, I'm going to be doing a talk after this where I talk about how to set up virtual networks and configure them and so on. So I'm not going to go into those details in this session. So just for you to get a high-level idea, if you click on Configure, it's going to give you all the configuration in terms of address space and so on about the virtual network. We'll go through that in the next session if you're around, and we can talk about it in detail. If not, I'd be happy to talk to you about it offline. So in this particular case, we have a virtual network. It's in the US East region, and I've configured 4 or 5 subnets within them for placement. And I've connected the virtual network to my premises using a site-to-site VPN. And setting up a site-to-site VPN is not rocket science. You basically click through a wizard to create a virtual network, and at the end, it will come to a screen similar to this. At the bottom of the screen, you have something called delete gateway here, but if you've created the virtual network for the first time, you'll see a Create Gateway button. If you click it, in about 6 minutes, you'll have a virtual network gateway ready for you that's highly available. Again, the same principles that we talked about today is what we use for our infrastructure. We realize that having this connectivity is going to be important for you. So we wanted to make sure that the connection is always available for you from at least from our side. So what we do is we actually run 2 virtual machines as pass roles in active passive mode. So the primary one will try to establish a VPN tunnel on the other end. For some reason, if we're updating the infrastructure or the physical server in which the gateway is running goes down, we have a mechanism by which we fail over in 30 seconds, and the one that was passive now becomes the active VPN device and establishes a tunnel back to your premises. So we have active-passive configuration. And I can talk to you about how we actually designed it so that if you're trying to build an application, you can use similar concepts to ensure you have high availability in active-passive mode. Okay. So that said, let's look at the SharePoint farm. So if you look at the tenant list in the screen here, you'd see a whole lot of virtual machines. So you have basically there are 2 data DCs. This is we had to have a domain controller for SharePoint. SharePoint uses identity pretty extensively, and we did not want to have just a single domain controller. So we actually deployed 2, and they are mirrored. The key thing that we rely on the virtual network is the fact that the network actually gives you stable static IP addresses for your virtual machines. So once you deploy virtual machines into them, they get IP addresses and they stay with the virtual machine for their entire lifetime. And as you know, the domain controller typically comes with a DNS server, so IP address stickiness is very important for DNS servers. So we created 2 domain controllers, and we actually have 2 app servers, 2 front ends, 2 SQL servers that are clustered with a server to ensure quorum, have all been deployed into the virtual network. Now, let's take the front end and actually zoom into it to look at the availability set and the load balanced set concepts. Yes? Mm-hmm. So there are a couple of concepts. So we have cases where you can deploy a virtual machine in Windows Azure just as a standalone entity. And the other way of doing it is to deploy a virtual machine into a virtual network. When you deploy a virtual machine into a virtual network, you actually deploy it into a private network, and you've picked a subnet for address allocation for that virtual machine. So you tell us from where we have to pick an IP address, and we pick an IP address. We sort of issue an infinite lease for you, and it stays with the virtual machine for its lifetime. There are a few exceptional cases there. Recently, we introduced a new feature that enables you to stop a virtual machine from a billing perspective. So when you shut down your virtual machine, we don't bill you for that. In that case, we really charge you for the resources that you consume in the platform. Now, when you stop these resources with your virtual machine, we actually free up those resources. If we free up those resources, we do release the IP address. So in such cases, yes. But our assumption is if you're setting up a highly available application for production use, you really will not stop your application. So in that case, the IP address stays with you. And you can reboot it when we move the virtual machine from one server to another, when we patch or update our infrastructure. All that shouldn't be a problem for you. You will have the same IP address. So that was one of the key features we had to put into the virtual network, primarily for the domain controllers. So let's actually zoom into the virtual machines and look at the front-end virtual machine so that you get an idea of how you configure availability sets and load balance sets. So by default, typically when you deploy a virtual machine in Windows Azure, it comes with some amount of security. It does not talk to any other virtual machine in the public internet. If you deploy them in a cloud service just by itself, only VMs within the cloud service can talk to one another, and it cannot talk out to the public internet. If you deploy these virtual machines in a virtual network, we have a larger boundary. The virtual network boundary is your trust boundary. Only virtual machines within the virtual network can talk to one another in the private IP address space. Now, you're setting up a SharePoint farm that you want to expose to the public internet. You have to actually configure a load balanced endpoint on the virtual machine. So if you say you want to open up port 80 and load balance it, you define an endpoint, and we go in the infrastructure firewall, we open up port 80, and we implicitly configure a load balancer, and you have to define a load balance set for that. So let's look at the front-end virtual machines to illustrate that concept. So just the way we looked at the dashboard of a virtual network, we're looking at the dashboard of a virtual machine. It gives you some useful statistics on the size and data in and data out and certain metrics like CPU usage, network bandwidth, and so on. Now, if you wanted to basically expose connectivity, you would have to click on this endpoints tab. That is where you configure different load balanced endpoints. You can actually define up to, I think, 50 load balanced endpoints per role in Windows Azure today. And each of these can be specific ports that you open up. When you configure a load balancer in Windows Azure, you're configuring a couple of things. The first thing you're doing is you're opening up the firewall in the platform. The second thing you're doing is you're basically configuring port mapping. You can say, open up port 5000 externally, which maps to port 10,000 internally. So you can do port mapping. Third thing you do is actually configure load balancing. So we do all these three things when you define an endpoint in Windows Azure. So in this particular case, when we actually provision a virtual machine in Windows Azure, by default, we open up a port for RDP so that you can remote desktop into the virtual machine and configure it. It's always exposed to the public internet. So RDP uses port 3389. That's what you see here. And we've done port mapping, and it's not load balanced. So every virtual machine through the public IP address can hit that virtual machine. So if you did the public IP address :port 65509, you would go to RDP into that virtual machine. On the other hand, if you're exposing it as a web server and you wanted to open up port 80, you can do that as a load balanced endpoint, and that's what you see here. That's the second endpoint here. The third endpoint we have here is for Windows remote management. So as I said, I deployed the whole SharePoint farm using PowerShell scripts. So in addition to just deploying the virtual machine, I need to go into the machine and do a lot of configuration. All that can be scripted and automated using PowerShell. And for us to be able to do that, we open up WinRM and set privileges in the virtual machine for us to go and configure it. So we do that using this port that we open up. So let's look at creating a load balanced endpoint. So all you do is go and click on this add button. It asks you to either add to an existing, create an endpoint or add it to an existing load balance set. We can give it a name. You specify the protocol and the port. And it's as easy as that. You've now defined a load balanced endpoint on port 443 on this virtual machine. This is my US West web front-end 1. So if I wanted to do this, I can go to the second virtual machine, which would be my US West front-end. It doesn't have the SSL endpoint. All I can do is say, add it to this load balanced set. For some reason, it is not letting me to add it, but the idea is the other option will light up where you'll be able to specify this particular SSL endpoint that you added, and it automatically configures the load balancer for high availability. Just the way we configure the load balancer, you can actually create an availability set and add these virtual machines into it. So when you actually add virtual machines into an availability set, which is shown under configure, here we have an availability set for the web front end, and these two are the virtual machines that are sitting within the front end availability set. What we do is when we see multiple virtual machines that are part of the same availability set, we place them in different fault domains and update domains. So as a result of that, you get high availability. So you place them as different tiers in your virtual network. And I said before, the objective of my demo was going to be to show you the fact that you have two identical SharePoint farms that are in two different regions for high availability and for disaster recovery that are both connected to my premises. So just to illustrate that, the on-premises in this particular case is my office in Redmond, and I have a pair of devices, F5 devices. If you look at this slide that we just showed you earlier, I have a pair of F5 big IP devices that are acting as my VPN device. They are configured in active-passive mode for high availability. So if one of the VPN devices goes down, the second VPN device can reestablish the tunnel and get it going. And we have a third F5 device. All these are virtual machines running in a physical hypervisor. So the third F5 device load balances these sessions across them. So let me show you how it works. So in this particular case, I'm logged into the hypervisor that's sitting in my office, and the web front end that you see here is for the F5 device that's acting as the load balancer. So I actually created a load balanced endpoint, and I said, I'm going to use HTTP 10.1.0.1 as the internal IP address to which I connect to if I wanted to hit my SharePoint form front end. And I have two front ends in US East and two front ends in US West. I added all four of them into that pool of machines behind that IP address and configured a probe on port 80. So the F5 load balancer constantly pings it on port 80 to see if it is available. And if I was to just open up a browser from a test virtual machine and say, go to 10.1.0.10, it actually automatically connects, picks a front-end instance and connects to that SharePoint form automatically. Okay, so now just to simulate a failure, I'm going to knock out a particular region, which is going to be US West. Let's knock out US West. So I'm just going to say disable them. So it's pulling them out of the load balance set, and this simulates an actual failure of that complete site.
Show them the picture.
So in this picture here, we are completely knocking out the US West data center, which is in the bottom. That's what we've simulated right now. And if I go back to my test virtual machine and connect using the same IP address, I'd still be able to connect to my SharePoint form because it's automatically detecting the fact that I have two front-end instances running in US East that's working. So you have high availability within the region, plus you have a DR site that's in another region. So essentially, your SharePoint form is actually highly available across the two regions. So that I wanted to show this because this demo kind of ties all the concepts together. There's one more thing where, as I mentioned earlier, I have two F5 devices that are configured in active passive mode. If I kill one of my F5 devices, I'd still have the connection fail over to the other VPN device, and that way my VPN tunnel is also highly available. So that kind of ties all the points together and shows you the fact that you can build a highly available application in our platform. See, there's one more topic that Yusuf is going to talk about, but I just wanted to show you since I'm actually in the demo machine. A virtual machine is all about having a durable disk for us. And we have to make sure that the disk is always highly available and replicated and so on. So we've invested heavily in our Windows Azure storage stack, which is not a SAN. And we use our storage stack to actually store the VHDs of virtual machines in Windows Azure. So that makes it highly available. And for your storage accounts, you can actually turn geo-replication on. So if you were to look at a storage account, which is where we typically store all our VHD files for all these virtual machines, you can see that there's an option for you to turn on and off geo-replication. If you turn geo-replication on, we have data centers in geo-replication pairs. So for US East, the geo-replication pair is US West. So we automatically, asynchronously do a replication of your blobs into that geo-replication pair region. So that way, your data is also highly available in the platform. So if you're writing applications that you want to store data in and you want to minimize the chance of data loss, you could put them in our storage blobs, and we take care of replication and making sure that the chances of data loss is minimized.
Great. Thank you, Ganesh. So guys, to recap, this is actually a very powerful system if you think about it. This is a highly available and highly disaster-tolerant SharePoint system that requires effectively no resources on premises. You are, in this case, what Ganesh showed you, and this was actually set up over a weekend. What he showed you is basically in two separated regions, and they're separated by hundreds of miles apart. You have in each region a highly available SharePoint farm, SharePoint, SQL, AD, the whole infrastructure, replicated in 2 places around the globe, and accessible in a very highly available fashion using your on-premises VPN devices. I know customers have spent, in some cases, months to set up something like this, to try to find data center space, find the ability to set them up, and so forth. And this is something you can actually do over a weekend. Okay. Let's move on, guys. And for the newer folks who arrived, what we've been doing is, speaking of high availability and disaster recovery for your applications, and using Azure itself as a DR site, as a DR destination or a source, if you will. And we're going through a bunch of technologies. Now we're going to talk about storage stack in general. And this is a bit of storage 101 for Azure, so bear with me if you know it already. But basically in Azure, we have, in the lowest level of the system, a highly scalable and highly durable storage system. You can have blobs. These can be very, very, very big files. You can have tables. You can have queues. Within a given data center, they are replicated 3 times. So every write basically ends up being in 3 separate copies within the DC. You can access them through REST APIs, and it's all documented, what have you, through your favorite language binding. And in addition, we have high availability and durability within a region, but we also have replication across regions. So it's same pattern we discussed earlier. HA in a given region, and DR across them. In this case, by default, all writes to a given copy end up being replicated asynchronously to a remote region. You can opt out if you don't want to. Some customers don't want to because of geopolitical reasons. You don't want your data to be away somewhere else. But otherwise, if you don't opt out, all your stuff will end up being asynchronously geo-replicated somewhere else. And the idea, of course, is that if we ever have to lose a region, which, touch on wood, we haven't had to lose a region yet, your data is safely available somewhere else. Okay? Now, there's some caveat I'll describe toward the end. And do remember, these are asynchronous replications. There's a window there between the write, making it in a given region, and propagating to a remote region. We do the same thing for your virtual disks as well, what Ganesh spoke of toward the end. Since our VM disks themselves are actually stored in blobs, and blobs are geo-replicated, you get this thing effectively as part of the system as well. So your images themselves, your VHDs as well, are also geo-replicated. And again, this stuff is in the platform, has been there for a while. So beyond the basic stuff, you have other options. Again, the following is optional. You can mix and match. We have the Store Simple solution I want to tell you a bit about. The top part of the slide is what you would typically do in a very classical sort of backup and restore of your data. You have to figure out what your primary data may be on premises. It could be a file share. It could be a SQL instance. You do some sort of a snapshot, depending on technology you have. Then you end up with some sort of replication. You put it to a tape or replicate it somewhere else. And you may actually have your tapes being shipped to a truck to some remote site. That's what we've been doing for many, many years in the industry. With Store Simple, you can have a much simpler solution that utilizes the cloud as your backup site, if you will. And moreover, you can, if you lose your local site, restore from the cloud back to a remote site. So with Store Simple, which is an appliance, really, you end up with automatic backup of your data. And you end up being, if you will, the stuff can move transparently to the cloud. Any local changes, again, transparently make it to the cloud. And you can do things like, snapshots for your data. And the benefits are very simple, really. It's a very simple solution to do. Simplicity is key here. You drop an appliance, you configure it, and it just it dribbles the bits out to the cloud. And in this system, really, you can test what you are doing. You can test that your copies make sense because you can snapshot them and then restore them periodically. And as I mentioned, you can use it to have a way to back up your data and then eliminate the problem of what do I do if I lose my site. So in this example, the left-hand side could be your production data, your main DC, if you will. So you have your stuff being running there, and it's being backed up to Azure. If you have a disaster and you lose your site, somebody cuts the fiber in the ground, not an uncommon function, to be honest, occurrence, or you have a fire, whatever, you can restore your data from the cloud to another appliance somewhere else and just mounting it, and off you go as well. And again, setting this up is as difficult or as easy as having an appliance in one site, an appliance in a remote site, and getting some Azure credentials, and off you go. Question? The question about encryption, are they encrypted by default? We don't actually encrypt stuff in Azure itself. It's up to you to encrypt them. Okay? I'm not sure if StoreSimple has an option per se, but the bits that make it up from whatever solution, it's all REST APIs. StoreSimple uses the same REST APIs as you can do directly. Those bits are up to you to encrypt them. So as far as Azure is concerned, there's no encryption mechanism in Azure itself. But of course, you can do it yourself. So again, StoreSimple is an option you have. You can actually do the whole thing by hand if you wanted to, because as I mentioned, what StoreSimple uses are the same APIs that you have access to today yourself. But this makes it very easy to do so. Another option is you can use System-Centered Data Protection Manager to take whatever assets you may have on premises, whatever Windows Server assets you have on premises, and back them up to the cloud. You can do it machine by machine by yourself using Windows Azure Backup, or you can configure a Windows Server instance, and your backups can make it up to Azure. And again, very simple workflow. Get an account on Azure, give the credentials to your software, and you go. Or you can use System-Centered Data Protection Manager and do it for a collection of machines on premises. And the good point is if you know how to manage Windows Server and you know how to do snapshots of that data, you can easily say, for the same snapshots, also please put them up in the cloud or bring them back from the cloud back on premises. Again, these are optional features. You can do it machine itself by yourself, one at a time. You can use System Center for orchestrating the whole sequence if you want. And again, I want to emphasize, all these technologies use the same public RESTful APIs. So you can script them yourself if you want to, or use whatever the system has for you. So we talked earlier at the beginning about virtual machines. We showed a demo how we combine them with hybrid networks. We spoke a bit about storage and some options. Let's talk about databases now. Okay, and specifically how to use infrastructure as services SQL instances to get high availability and DR. So now we support SQL Server 2012 on IaaS instances. In other words, you can take SQL off the shelf, configure them in a VM, and up and run them in the cloud. And you can do them using SQL's availability groups, which is part of the SQL system itself. So it's an HA story. Running in a cloud in a given region, you can have a Windows Server, basically failover cluster that's running SQL. It's always on, basically. And in this system, you have a primary replica of your SQL data with synchronous commitment and replication to a backup, and whatever else you may have for your solution, like a witness for a third vote, if you will, including also things like a domain controller, or whatever the case may be. We have this thing documented. There are white papers on the subject, and it's very easy to set up, basically, without any hardware you have on premises. And the beauty of this, you get the full power of SQL. The full power of SQL always on, basically. So this gives you a highly available solution within a region. Now, you can use this, you can combine this with the virtual network we discussed earlier, and then have a way to do disaster recovery as well. And this thing, we flipped the picture here a bit. You have an on-premises network using, again, you have SQL with SQL availability groups. You have high availability on-premises in this picture. So on-premises, you're highly available with replicas being replicated. But also you can configure it to do asynchronous replication to a SQL instance running in the cloud, which is hooked to your on-premises network using virtual network that Ganesh showed you. So you have synchronous, high availability on-premises. async replication for disaster recovery off to the cloud. And by the way, you can flip this picture if your business wants it. You can flip it. You can be running most of the time in the cloud and doing asynchronous replication back to on-premises. And if you know how to manage Windows Server, if you know how to manage SQL, this will look to you very, very familiar. Setting up a bunch of VMs, otherwise it's the same interfaces, same mechanisms you would do if you do it purely on-premises. And the key building blocks are infrastructure as a service, because you can run your VMs, virtual network, because you can connect them, and everything else basically is just basically Windows. And you have other options as well, where you can do SQL Server itself backup and restore up to the cloud. And this is a very simple example. You may have a single instance of SQL Server running somewhere else, and using standard SQL Server Management Studio, configure it to do both backup to the cloud and restore from the cloud as well. And again, guys, you can mix and match many of those options I gave you on these pictures. Okay. So we talked about the building blocks. Let's talk about how to actually manage all these things together. And again, many options here for you to, depending where you are coming from. You can always go through, before I go to this one, you can always go through the portal that Ganesh showed you. And if you stay for the next talk, you'll see more of the portal as well, which is very easy to use. Okay. In some scenarios, you may want to do things beyond what the portal can do. So we have other options as well. If you already have a System Center system installed and using it, you can use it actually in multiple ways to manage services you have between your on-premises and Windows Azure. And in this case, you are basically having the System Center give you the way to some basic role-based access control for your assets in the cloud, and a way to monitor all your applications, be they running on-premises or in the cloud, in a very seamless fashion. And in this particular example, App Controller, which is a module or a part of System Center, gives you those abilities. You get your credentials from Azure, you give it to App Controller, and from there on, it becomes your single pane of glass to view your assets and to monitor your assets, be they on-premises in Windows Azure or, frankly, other service providers as well. Same single pane of glass. And technically, by the way, again, this technology uses the same APIs that are available to you directly anyway. So underneath this whole thing, we have a powerful set of PowerShell commandlets for you, built over the RESTful APIs. So everything I told you, you can do this, you can do that, you can actually invoke them yourself directly. You can script them yourself directly. Broadly speaking, we have 4 categories. Automation, which has to do with setting up the VMs, setting up the configurations, and so forth. We have the ability to do things like using PowerShell to set up your domains, AD, joining, and what have you. All the virtual network technologies we have for configuration, you can script them as well. This includes configuring the virtual networks, managing the configuration, the gateway, and how to connect them, and so forth. And for the storage system, you can access storage directly, you can configure storage as well, and you can do things like copying the data asynchronously between them as well. We are committed to make sure that everything we have in the platform is available as a RESTful API, and with at least PowerShell available to invoke those APIs. You can also, if you are more into programming, call them as well directly from .NET or other languages, as the case may be. If you've been watching us in this project for a while, we started more of a portal experience, but we quickly realized that we need to, clearly for IT scenarios, for IT admin scenarios, to have a full-class experience for scripting for the system. And that's what we're trying to say here. Lastly, we also have partners out there that you can go use their systems if the scenario makes sense to you. So one such partner is RightScale. RightScale have their own ecosystem, if you will, their own management infrastructure, their own monitoring, their own APIs. And they integrate very strongly with us and with other third-party public APIs, by the way, public clouds, by the way. So if you are part of that ecosystem, you can use RightScale to do all sorts of things to manage your applications, utilize the power we've been discussing here in terms of VMs, the hybrid network, and so forth. And through very simple templates, do things like build up a configuration for your service and run it anywhere you want to, with the RightScale supports. We have other providers in the marketplace as well. And again, guys, the way this is implemented, through the same APIs that you can go directly access as well. Okay. Let me just tell you a few limitations that may have come through in this discussion, but I want to make sure it's very clear to you. One is that today, we do replicate all your rights to storage between one place and the other, one region and the other one. However, you do not have control over when you can fail over from your primary to secondary in the system. So this is basically just for disaster recovery today. That is, if a region is not available for a long time, we will flip it over transparently. So far, we haven't had to do this, and we don't want to do this. But this is important for you to realize that if your scenario requires you to be able to get to your secondary while your primary is up and running, you have to do your own replication some other ways. Okay? So again, you don't have control when to flip over the storage. And moreover, you cannot access the secondary while the primary is active. Okay. Hopefully, in due course, we will remove those limitations, but today they do exist. The other thing I want to point out is, for all the DR scenarios where we discussed, yes, you can take some capacity and run them from on-premise up to your cloud, or when a given region goes down, run somewhere else, you need to plan in advance the capacity for you. So for example, if you have an important application and you're running 1,000 VMs in one place, and you require that if a disaster happens, you have to be able to get at least 10% of your capacity, make sure 100 of those VMs are up and running somewhere else. In other words, reserve capacity by actually running something. Your business would dictate how much you want to reserve. Probably not 100%, maybe a smaller percentage. But if you really want to make sure the capacity is there when you need it, make sure you reserve it in advance. Yes, please. Yes. Not in the same region. So question is, what happens if a disaster actually happens, and what happens to our capacity, if you will? What we do is that we ensure that if we ever lose a region, and again, we never had to lose a region, is that collectively, globally, we have capacity for it. So you're not guaranteed necessarily that your compute VMs will land in the proper region. Okay. It's not ideal, but it will work. It's not ideal because of latency, of course, and maybe geopolitical issues. But we cannot guarantee we have the exact same capacity, replicate to N. That would be really prohibitive. But in an N+1, N+2 type of configuration, we have that. Lastly, today's the SQL availability groups, you cannot configure them across Windows Azure regions. So you can configure them within a region. You can configure them between a region on-premises or vice versa, but not between regions yet. We will remove the limitation in due course. Okay. Let me summarize, and I hope to leave. We have some time for Q&A, some questions if you have any. So in summary, you get VM resiliency in a given region through availability sets. You basically tell the platform, you can combine together these sets, and we know that you are partitioning your application in such a way as you want to make sure part of it is up and running if one part is down. You can extend your infrastructure from on-premises to the cloud using virtual networks. Actually, you can extend them in multiple ways, as I mentioned earlier, point to site to site, and so forth. You have durable writes to your data, plus geo-redundant replication in the basic Azure storage system, which includes your Azure VM disks as well. So your writes are written multiple times in the same data center for availability and durability, and they are asynchronously replicated to a remote region, unless you opt out. Now we can, using our new infrastructure, take SQL Server 2012 availability groups and actually extend them between your on-premises and the cloud. Because this is a very powerful feature if you're doing the SQL space by any chance. You have options like Store Simple, which can give you a very simple way, very quick to market way of dropping an appliance in a site and having a multitude of disaster recovery solutions. Back into the cloud, backing from the cloud to a different site, and so forth. You can configure Windows Server to back up its data in the cloud. You can configure System Center Data Protection Manager to manage a bunch of servers you have on premises and back up your data to the cloud or restore from the cloud. And everything I told you, you can script yourself if you want to. You can script it using PowerShell, and underneath them, if you want to go do the actual programming, you can use RESTful APIs as well. And we have partners and many tools out there. I mean, RightScale is one such partner. We mentioned F5 is another partner who are building, if you will, value added over the base platform for manageability, for HA as in F5's case, or for dev and test scenarios and so forth. Okay, guys, this was a very high-level presentation. We have some time for questions here. And if you want to know more about virtual network, stay in the same room. And Ganesh has another talk just about virtual network here. Okay? Any questions? We're around. Thank you.